And
Hello,
we
hello.
should be live. I know it can
Hello,
take a minute,
hello.
so I'll double check the streams. How's it going, everybody? How are you doing, Sean?
I'm doing great, and learning that I'll be doing this with you yesterday, and quite excited to joining.
Well, I'm excited that you're here. Let me just make sure the streams are starting. And for anyone watching, let us know in the chat a little bit about yourselves. At least, maybe where you're watching from. That's always a fun thing to share. But also, it's great to hear about your experience with machine learning. Have you trained models? Have you put models in production before? Have you ever implemented ML monitoring on models? Have you used a model store before? Any of those questions would be fun. And we're just going to wait a minute or two before we get going into the content. So if you have any questions, you can also throw them in the chat already. But really, it's just fun to hear about a little bit about the audience watching. And I think I see someone. Oh, Bo posted a bento emoji, which I love. I also love that with the BentoML that you have a great emoji that you can react with and share. We gotta find out what that's gonna be at WhyLabs.
Yeah, just got to be creative. I don't know if this came up when the name was decided, but it's definitely a perk at this point, looking back.
Yeah, yeah. We have like some cute logos and stuff, but they're not like just built-in emojis. I need to figure out what it would be. We do have a dog as part of our thing. Actually, in the slides, I'll go ahead and share the screen. We have a dog, so maybe we could have a dog one. And I like to joke around. I don't know if this is in the official naming either, but I like to say that that's the Y Lab. And then we have a little robot as well, maybe with some eyes. Maybe two eyes would be good.
Oh yeah, I can put the two of those together. That's very creative.
Yeah. Perfect. Yeah, or like the two eye emoji. Maybe it's like monitoring, looking at your models. That
Hmm.
might be good as well.
It
Somebody
might be
said,
it might be too intense.
somebody said hello. Hello. We're just waiting a couple minutes. We're gonna get going here in a second, but I see some people joined in, so feel free to put in the chat. A little bit about yourself. I think it's fun connecting with other people in the audience. For us presenting, but also for anyone else in the audience, I think it's more engaging, kind of seeing, what other people are doing or why you might be interested in this workshop, and maybe a little bit about your machine learning journey. It's always fun to hear about. But with that, we'll go ahead and get going through some of the slides. I'll talk about this again in a second, but we're going to start with several slides, not that long, and then we'll go into kind of a hands-on example. And let me put this in presenting mode. Oh, actually, before we do that, I'll just do a couple links for housekeeping. And these are in the link in the description. So if you're watching on YouTube, you can go to the links in the description. But I'm going to post these in chat as well. So this is the GitHub link where if you want to run the hands-on code today, or just save this for later, this is a GitHub repo that has the example that we're going to be running through, as well as the setup instructions. But if you want to do a little bit of setup, you could already git clone this locally on your machine and pip install the requirements if you want to run along with us. And then I'll also share this real quick in the LinkedIn chat to make sure people over there can also follow along. And also in the LinkedIn chat, I'm going to share the YouTube stream because I know sometimes people might want to hop over and watch this on YouTube. And all the links are in the description on YouTube. But I know LinkedIn, I don't think you can click on anything. You have to like copy them in. So it might be easier if you switch over to YouTube if you want. And then I'll just go ahead and share. We're going to be using a couple open source libraries, one called WhyLogs and BentoML. And if you want to check out these GitHubs, you can as well. And we always appreciate a star on our open source work. So if you want to give us a star, that'd be great as well. And with that, we'll go ahead and get going. So welcome everybody. We're going to be talking about model serving and monitoring with BentoML and WhyLabs. And we'll do intros in a second. But I'm Sage from WhyLabs, and we have Sean, head of engineering from BentoML with us. So what this workshop is, hopefully it's a super friendly introduction to serving models and monitoring with BentoML. So, kind of designed with not much experience expected, but definitely knowing some Python and machine learning will be helpful. And knowing how to run some Python locally will be helpful if you want to follow along and run the code. But even if you don't do that, I think you can get a lot out of sticking with the workshop. So we're going to cover some high-level concepts in the slides first, which won't take too long. And then we're going to go and do some hands-on code examples. So just keep in mind, you can't learn everything in the hour. Parts of this could feel fast-paced or challenging depending on your experience level. That's totally okay. And if this all seems interesting or useful to you, just keep learning after the workshop. And you can also connect with me or Sean and ask us questions on LinkedIn or either of our Slack communities. A quick introduction about me. My name is Sage Elliott. I'm a machine learning and MLOps evangelist at WhyLabs. We create tools to enable AI observability and ML monitoring and data monitoring. We're going to see some of those in action today. For over a decade now, I had to think about how old I am. I've worked in software and hardware, mostly with startups and a few consulting agencies around Seattle and Central Florida. And in general, I love making things with technologies. And trying new stuff out. So I always have a ton of different side projects going on. So if anyone ever wants to talk about like hobby robotics or something like that, you could also message me. And then, Sean, do you want to do a quick intro about yourself?
Yeah, absolutely. I'm Sean Sheng. I support everything engineering at BentoML. So BentoML is an open source platform for building, shipping, and scaling AI applications. I think Sage reserved a slide later for me to talk about this a little bit more in details, but about myself, I also spent a few years in Seattle, absolutely a beautiful city, especially in the summer, starting right around this time. Um, I enjoy working on distributed systems, powering products at large scale. I used to do it for teams and product at Microsoft and LinkedIn, but now I'm very excited to work on the open source and serve teams building very cool products around the world.
Awesome. Yeah, the weather right now in Seattle is like just starting to change. We're getting some really beautiful days and then it goes back to being rainy. So I'm definitely excited.
Yeah.
I fixed up my bike. I'm ready.
April shower bring May flowers, right?
Yeah, exactly. About you. So again, I saw more people join. If you want to throw in the chat, where are you watching from? I think that's always a good bare minimum to answer. And then also, if you want to throw in there, why are you interested in, the things that BentoML and WhyLabs do, like model serving, building AI applications, and ML monitoring. If you want to throw a little bit about your project in the chat, that'd be great. Or if you just want to maybe answer, have you ever put machine learning in production before? I think that's fun to hear about. And then if you want, you can stay connected in the Robust and Responsible AI Slack. There's a link to that in the description as well. And then also, if you want to stay connected with the people at BentoML, I don't remember if I put the link in the description, but if you go to bentoml.com, there's a link to their community as well. And
Everything is good. Google search away.
yeah, BentoML, WhyLogs, you should be able to find most of the stuff you need. And I think both of us have, introduction channels and stuff. So I always recommend people go to at least one of those Slack communities and introduce yourself there for, us to stay connected with you, but also other professionals and people in the audience. A quick note about the setup. So again, I'll share this link in the chat. This is the repo we'll be working from, and it should have most of the links. And then it's also in the description. And then one other thing is you'll actually want to create a WhyLabs account. It's free. There's no card required or anything like that. It just takes like a minute, and you just verify your email, and you'll be ready to go. We're going to be using that as part of our workflow today. And then the main libraries that we're going to be talking about is BentoML, which Sean introduced a little bit earlier, WhyLogs, which is a data logging and ML monitoring library. Both of those are open source. And then we'll be using scikit-learn to train a model. And then we'll be using WhyLabs to kind of set up alerts and analyze our logs. All right, so Sean, this is your slide if you want to talk a little bit about what is BentoML.
Yeah, thanks, Sage. So we believe that moving forward, pretty much all apps will turn into some sort of AI apps. They will be using models trained either from your own data or fine-tuned pre-trained model from open source. So this way, the apps will be able to do all sorts of different complex tasks more easily with the help of ML models. But in order to do that, complicated pre-processing is required for data normalization, transformation, feature engineering, just to name a few. Or with the recent popularity with LLMs, apps can perform embedding lookup or similarity searches to enhance the performance of these large language models. Next, addressing the challenges associated with serving and scaling machine learning models themselves can be quite challenging. It's important to run models on the most optimal hardware, such as instances with multi-core GPU, to maximize their performance. However, these instances can be quite expensive, so you want to scale them automatically based on usage and not just leave them running at all time. Um, Simultaneously, you want to achieve high reliability and low latency for your model serving uh, uh, at, at the same time. Um, Finally, the AI application needs to be able to integrate with ecosystem components like WhyLabs for model monitoring and inference data collection. So in a nutshell, building AI application can be really hard from scratch. So with framework like BentoML, it simplifies it by providing the tools and infrastructures needed to streamline your AI application development cycles, which you'll soon see in action. So yeah, back to you, Sage.
Awesome, thank you. Yeah, and just to touch on the flexibility of BentoML is really cool. Like you were saying, being able to integrate with all these different other tools like YLogs or other open source tools you might want to use. Like when I started using it, I was like, oh, this is so easy to get started, but also kind of bring in all the tools I need together, which is really exciting. So again, yeah, we'll see this in action in a little bit. All right, I'll just talk a little bit about what is ML monitoring and WhyLabs. So when you put a model in production, again, if anyone wants to put in the chat, have they put a model in production before? And if so, have you experienced any of these things I'm going to talk about? And I won't go too in depth here. There's a lot of stuff that you can cover around ML monitoring. I do those in a lot of other workshops, and if you ever have any questions about those, reach out to me. But you have things that can change most of the time. If you deploy a model into production, data is going to start looking a little bit differently than your training data. And you could have something that happens called like data drift, where you might have a new group of users, or seasonality changes your data, your input data to your model, and your model might not be performing as well. So there's like a drift in the data, and it starts looking different, and potentially that's probably going to be making your predictions on your model less reliable. You also have data quality issues. That could be all sorts of different things, from people manually entering it wrong, from a sensor going bad. You could have schema changes. From your model output, you can have concept drift, where your model output's no longer really mapping to the values you want. One example I always use is like the housing market. If you trained a model 10 years ago on housing data, the data itself didn't change, like the number of rooms or square footage, but the output of the model, let's say you're predicting the prices of a home, that drastically changed, and so it's no longer really mapped to these real world values. So you'd want to retrain your model because it kind of went stale. And then you have the performance metrics you might have heard about or used in machine learning, like accuracy, precision, and recall. You also want to measure for like business KPIs and bias and fairness, making sure your model isn't behaving weird on certain segments of your data. And these are all kind of things that you can look at in various ways and set up monitors, in this case with WhyLabs, so you get like alerts about it, or you can trigger workflows to like kick off a data annotation job or retrain a model and then shadow deploy it and see how that new model is performing versus your old model. We have a saying that is bad data happens to good models. So your model might be perfect before you put it in production, but data is going to change somewhere probably. Just as a high level picture of what this architecture might look like for ML monitoring is you have your model deployment, maybe your feature store, you're going to be want to collect certain statistics around what's going on there, like certain telemetry, how your input data is behaving, how your model output's behaving, and then you want to analyze and measure that in some capacity. And then from there, you can do those things like I mentioned, like you can look at these reports and dashboards, you can get alerts and notifications, and then you could also trigger off automated workflows. And just to mention one more time about ML monitoring, it can be pretty complex. So we have users that will set up monitoring at various stages in their pipeline. Your pipeline could be pretty big and have a lot of different things around pre-processing and multiple inputs and outputs. But at a bare minimum, if you're just getting started with ML monitoring, I always recommend just to monitor the model inputs, so the data that's directly going into your model. And then ideally, you could always get ground truth, but that is quite time intensive a lot of times and you won't be able to have it. So you can monitor just the model outputs. And with just the inputs and outputs, you can actually learn a lot about how your model's behaving. And we'll see this in action in a little bit, but you'll be able to see, is there a drastic change going into my model? And then you can hopefully kind of see that your model predictions are changing and kind of debug your model that way. So enough slides. Actually, I have one more slide. I forgot to remove that one. This is just the setup slide again. So again, like I said, slides were going to be pretty quick, and now we're going to go into the code. And I see some people just joined. So again, this link is in the description, but I'll share it in the chat again as well. This is the GitHub if you want to clone down this repo and install those requirements in your own Python environment. You're welcome to follow along, or you could just bookmark this and come back to it later if you want to reference it. And then one other thing is we're also giving away some WhyLabs swag. So there's a little survey. I'll share it in the chat here. Also share it on LinkedIn. If you want to fill out the survey, you'll be entered to win some WhyLabs swag, and then we'll get your address and ship it to you. And we have cooler shirts now, by the way. You might get this one. It says no more ML oops, and it's got our little Ybot logo on it.
Love
and
it.
Then you also want to create a WhyLabs account as well if you want to follow along. And I'll exit out the slides, go over to the code. And the chat's been a little quiet, so I just want to say hello again to everyone. I know I saw a whole influx of people join, so let us know in the chat maybe what you're working on, why you might be interested in BentoML and WhyLabs. It's always fun to hear from the audience. And so I have code. I'm going to try to zoom in. And this GitHub also has setup instructions, so even if you're pretty new to Python or programming, as long as you have Python installed in your library, you should be able to kind of run through all these, or installed on your computer. You should be able to run all these steps and install these requirements in your environment. So if you have your own Python environment like Conda or something like that, you can feel free to skip these steps and then just pip install the requirements.txt. But if you just have a Python environment and you're kind of new, you can set up a virtual environment built into Python just using these steps. And then install the BentoML and WhyLabs libraries that we're going to be using. And yeah, it's just a few libraries: BentoML, WhyLabs, scikit-learn, NumPy, and pandas. So you could also manually pip install those if you want as well. So I'll give everybody just a few seconds to kind of catch up to that if they want to, and create the free WhyLabs account. We'll just get a couple keys from that in a little bit to put in the code in a second. So in here, we have several files I'll walk through as well. And the README also does a little bit of walkthrough, but so you can go back and read that later if you want. We're going to start today by using a file called train.py that's going to train our model and save it to the BentoML local store as a version. And then we're going to use service.py to create an API and run this. And then we're going to look at that input data and model outputs like we had talked about, and then log that with WhyLogs to WhyLabs. And then we're going to come back to this file a little bit after that. We're going to log a reference profile. So we're going to take the training data set, create what's called a reference profile, send that to WhyLabs, and then we're able to compare any new data coming in directly to the distribution in the training data. So it's a good way if you're getting started with ML monitoring and you don't have any production data yet to kind of do any other method of like a rolling window comparison between data or anything like that. You can already take the distribution of training data set and then compare new data directly to it, and it will tell you, does this look very different? Maybe we should see what's going on with that data. And then I have one more file here. We won't use this today, but it's a different method of implementing WhyLabs with BentoML using something called a rolling logger. So if you're getting a ton of requests, you might want to use this, and it'll just kind of merge all those requests together and then send them up in different intervals. So we'll start with this train.py. And in the terminal to run this, well, I'll go ahead and run it and then kind of explain it. So it just takes like a minute to train this model, I believe. So you just type in Python train.py, and that was way faster than it did last time I did it, so maybe I'm using less hardware resources or something right now. But you'll see we got this little output with a tag, and this is our trained model saved with BentoML. And just to go through the code a little bit here, and Sean, feel free to jump in if you want to talk any or mention anything about BentoML. We're just loading in the iris dataset, classic. Everyone's probably used this before if you learned machine learning. We're getting our feature values and our target values. Then we're just training a k-nearest neighbor with the neighbors of 5. So it's looking at basically the closest 5 neighbors to the new piece of data, making a decision of what class this belongs to. In the iris dataset, there's 3 classes. We'll see what this looks like a little bit later when we start making our predictions. And then here we're using BentoML to save a model. So we're calling save model from BentoML, scikit-learn. And I should mention, I think it's in the README, BentoML integrates with basically any ML library you're going to be using. So if you are using like PyTorch or TensorFlow or something like that, you can save your models very similar to this.
Yeah, what you see on the screen here, for example, it's the sklearn framework integration with BentoML, but you can imagine replacing sklearn with anything your favorite ML frameworks, whether it's PyTorch, TensorFlow, or you can import transformers or diffusers model from Hugging Face. There is a framework integration in BentoML for that.
Awesome. And I think I could be wrong. I think you have a really cool blog post on using like diffusion models or something. I feel like I saw that.
They are. Yeah, there's a stable diffusion example serving that with BentoML. So look it up.
Awesome.
It's Google search away.
So here we're calling this iris knn as the title we're giving our model. We're passing in our knn neighbor, and then we're passing a few properties that we're going to be able to call on the saved model. So we're going to use the predict property to make the prediction of what class it belongs to. And then also in scikit-learn, there's the predict probability property, and that's going to give you kind of a score of like the confidence that it belongs to that class. So if it's looking at the 5 closest ones and 2 of them are one class and 3 is another class, it's going to say, well, I'm like 60% sure or whatever that it's the class that is the closest 3. And that's all it takes to train a model. Very simple. Again, like we're saying, I think the way BentoML does this is really cool. It's easy to train and then save your model using the way BentoML does it. And now we have a version. And you could save multiple versions locally and do experimentation that way, I guess, right?
Yes, absolutely. So the version number here is generated. You can specify your own. So whether that's in the 0.0.1 version scheme or anything that you follow. Keeping models be able to catalog in their versions, we believe is very important for model serving in production. So what is being served at what time, and simplifies collaboration across different teams and within your own team.
Absolutely. And I think you have a model store type project as well, right?
Correct. So what we are doing here is saving the model in the local store, but that's just sitting on your hard drive. We also have BentoML Yatai, which offers a repository of models hosted in the cloud, so you can push and pull models from there, just like your push and pull Docker images, if you're familiar with Docker.
Yeah, that makes it way easier for collaboration, like you're saying, because you might be doing experiments with same models, and deploying them from different spaces.
Yeah,
So super
absolutely.
cool.
So Sage can just, do a BentoML push with the same model that you see on the screen, and I'll be able to pull it down and start uh, experimenting, running the model on my site or deploy it to anywhere.
Yeah, that's awesome. And like I mentioned, part of the ML monitoring or really just deployment process for most people is, your models aren't just deployed once and then they stay there. You're collecting new data once it's in production, monitoring that data like we had mentioned, and then, annotating and potentially retraining that model with new data. And then you could do something like a shadow deployment where you have a new version of this model, and then you deploy it out, and you could be looking at the comparison of the model performance between like these old ones and that new one, but now they're all like versioned. So it's not just like some model floating around on someone's computer or you're pushing it up somewhere. This makes it really easy to reproduce this model in all those different locations that you might want to be deploying to or experimenting with. So super cool. Thank you, Sean. Now we're going to go over to service.py. So now that we have our trained model, what we want to do is create an API endpoint so that then we can start doing predictions with this. So we can go to an endpoint, pass it some data. In this case, the iris data set is just 4 features. We'll see this in a second. We want to give it a list of those features and then make a prediction on it. Before we do that, if you're following along, I'm going to get these 3 things from WhyLabs, which is where we're going to be sending our data to for ML monitoring. So I'm going to go back to my browser. And if you created a WhyLabs account, you should go to it and have a home screen that looks something like this. You might have 1 or 2 toy projects in here to start with. I'm going to go ahead and go to Create Project, and then I want to go to Setup Model. So we're setting up a new model here. If you want to, you can also delete those toy projects. So if you do have one too many or something like that, I'll go ahead and delete this old BentoML one I did. And then I'm going to create a new project. I'll go ahead and call it BentoML again. So if we do want to log performance metrics later, WhyLabs can take care of that calculation for you. So add model or data set. By default, the batch frequency is daily. So you're going to be logging data, and it's going to be kind of merged together in a day profile, and then look at how that day compares to other days. But you can set this to different batches. So now we're here. We have this model number. I'm going to go ahead and copy that and go back to our code. And I'm going to paste that into my project ID here. Make sure you don't get a new line character or any spaces in any of these. So now that we have this model number, I'm going to go to this little access token tab up here. And I'll just make a new API token. Again, I'll call it a BentoML, create access token. Just copy this, go back, put it into your API key slot. One more thing is we want to get org ID. So you get multiple orgs. And that's on this page here or over here. So just go ahead and copy that, paste it in. Again, make sure you didn't get any spaces or new line characters in there. And now we should be able to run this. And again, we'll talk through the code, but I'm going to go ahead and take this command here, and I'll paste it in my terminal and run it. And now we're running our BentoML server locally on port 3000. So we'll go look at this in a second, but I'll talk through the code real quick. So we imported our libraries. We set our WhyLab tokens. We just have a list here of our class names. So there's these 3 classes in the iris dataset. Setosa, Versicola, Virginica. And then, and Sean, you can talk more about this if you want, but we're initializing our BentoML runner.
Yes, so here is the basic symmetrical API to save model now that you can get a model back. The iris KNN, the latest, which is the latest version of the model you saved. And what we are doing here is convert it to a runner. Runner is an abstraction in BentoML that represents the abstraction of a compute. So in this case, the compute is model inference itself. What this allows BentoML to do is to be able to scale and even deploy the model runners independently from the API. So that because model runners, it's sometimes advantageous to run them on different hardware profiles compared to the API. Maybe you want the GPU running on it. and scale independently because model compute is different compared to API compute. One is more maybe GPU and CPU intensive, compute intensive, compared to API, which is more IO intensive. So you want to be able to run them separately and scale them separately. And in addition, with a runner, you can do things like adaptive batching so that you can batch your input together and feed it to the models to get more efficient performance out of it.
Awesome. And then we're creating our service with that runner.
Yeah, so a service is what you will see soon with that BentoML serve command. You'll bring that service online behind a port accessible from outside your Python program, and providing the runner in there for the service, so it knows that the runner is part of the service in addition to the API.
Yeah, and then you use that as a wrapper around the prediction class in this case.
Correct. And the next thing you see on the API is where you can define your custom business logic. At the very top in the API decorator, you specify the type of input and output that you want from here. So in the case we see on the screen, the input is a NumPy ND array. We can create the ND arrays. We can specify the schema basically from a sample that Sage has provided in here, which is an array of 4 floats, and output is a text. So these can be mixed and matched. So you can have input of a tensor, output of pandas data frame. I don't know anyone will do that, but these are independent. Next is the actual API function. So the arguments in the function is what you have specified in the input. So in this case, it's the ND array. The business logic, you can pretty much do anything in here. It's Python. You can call downstream API, you can fetch data from database, call a feature store, look up, calculate embedding, and look up in a vector store. So all of that you can do within this function. You have quite a lot of flexibility. And yeah, as long as you return the response in the form of text, so in the form of string, so it's the API is quite flexible as long as you adhere to the input and output contract that you have specified.
Awesome. Yeah, and in this case, we're just using that runner, which had our model, and we're calling that predict function on it and the predict probability, and we're just getting the and we're obviously using the new data that's passed in the prediction endpoint, calling those predict and predict probability, and then we're just kind of logging those in different ways. So here we're getting the categories from that category list from that result, and then we're getting the max probability, that's a list that's returned from that predict proba. And then here I'm just creating a dictionary in Python, and I'm passing all these things together. So I'm getting all those feature values, and I'm also getting the predicted values, so the category and the probability that was predicted. And then I'm going to create use this dictionary, and I'm going to call y.log on it, and this creates a profile of that data. And we'll see what's in a profile in a minute, but essentially you could be in this case, we're getting one at a time, but you could have like, again, let's say you had a data frame and you have like 100 different rows, and you log that data frame, you're going to get these summary statistics with ylogs. So there's a little bit more to this, but you could think about like having the min, the max, the median in your tabular data. And the cool thing about that is that it doesn't contain your raw data anymore. It just contains these summary statistics. So one, they're really lightweight. So you're not really spending a lot of compute or a bandwidth like sending this sometimes really big raw data files. You're sending really lightweight summary statistics. And then another thing is useful about that is that if you're in an industry like healthcare or finance, you might be a little bit more picky about where you send your data to. And so these profiles are very secure. They just contain these kind of summary statistics about your data. So we've had people come in saying like, no, we have to use an on-prem solution or something like that. But then when they realize that it's just these summary statistics, they can be okay with sending those out to like WhyLabs platform in this case. And I'll just mention here we're logging that data, and then we're writing it to WhyLabs, and we'll go see what this looks like in a second when we go pass data into our API endpoint, and then we're returning the text category. But I just want to mention that in this case, we're using YLogs, and then we're writing those profiles to WhyLabs. You can use just YLogs on its own. It's a pretty awesome standalone library. You can even do things like detect data drift with built-in functions to YLogs. And you could write those profiles locally. So in this example, we're writing them to YLabs, but if you wanted to, you could write them to your disk. You could write them to an S3 bucket, kind of anything you'd imagine. Again, like there's a lot of flexibility, just like BentoML, which is awesome. And then also you might want to add something here if you were actually using this in production to maybe save your actual data locally in your environment, at least for some amount of time. So for example, you might be using these statistical profiles and detecting if there's data drift. If there was data drift, you might want to go get that raw data, annotate that data, and then retrain a model with it. So just a couple things to mention there. But now we have our endpoint running. And if you're following along, you should as well. So I'll go back to my browser, and I'll go to port 3000, and we have this Swagger UI for our endpoint now. We can see that we have a post endpoint here that we can pass data to. And if we open this up, we can see it gives us the schema of what the data should look like from what we defined in the code here. And we can hit try now in this UI, and we can actually pass data in this way. If you want to, you could use curl. I have an example of that in the GitHub repo as well, or Postman or something like that. But I love just using this UI. It's awesome. You get a model that's deployed, and you can start interacting with it. Let me see if I can zoom in a little bit for everyone as well. So here we have some data. I can go ahead and hit execute on this. Let's see. And then we can adjust this data a little bit as well, so we can make it look way crazier. And we got response 200. That's good. And our prediction was Setosa. So that was like really easy for us to train a model, save a model, and then get an endpoint up really in a few minutes, which is awesome. And then we'll look at what this data looks like as we're passing it into WhyLabs as well. So let's go ahead and hit execute on this a few more times. And I'm just going to go a little crazy with the numbers here. The point is to show that we can predict or detect data drift and stuff. So let's go ahead and just, feel free to, if you're following along, it doesn't really matter. Just, add numbers to these, and we're just going to make predictions on them. And we'll see that it thinks it's Virginica. And one thing fun to note here is, like, when I used to teach machine learning and use like KNN as an example or something like that, and people are always like, how come like this is so far out of the distribution of any of our training data set, how come it's still making predictions? The way KNN works, if you don't have data validation or anything in your pipeline, is it doesn't matter. You could have a really, really large number, a really tiny number that's outside of the training prediction, and it's still just looking at those closest neighbors. So like this could be so far out of your distribution from your training data, and it's still saying, well, the closest ones, even though they're incredibly far away, are these classes. So kind of a fun thing of like, you should know a little bit about your models and how to debug them just by like looking at this. If you saw a crazy large number go in and it was making those predictions, that's why. And
that's why it's important to do data validation in your API to make sure that you detect things like this.
Absolutely. And I don't think I mentioned this. So we're talking about using YLogs and WhyLabs to monitor for model drift, like data drift, but you can also use it for data quality validation. So you could run something called constraints. And again, there's examples in the GitHub, and I could talk about them a little bit more later. They're not used in this workshop, but you could set up constraints to look at that data and say, is this over number 15? And is it like less than 0 or something like that, or greater than 0? Then, throw an error and actually don't run that prediction on the model and do something else instead. Or at least like flag it as like, this looks like it's way out of the bounds. You could actually do that with YLogs as well. So I'm just doing a few numbers here just so we can get a profile. And again, you could just do high. You could do very low numbers. I'll do a couple low real quick. One more time. And that one thinks it's Setosa. All right, so let's go back to WhyLabs. We set up our project. If you click WhyLabs homepage, you should see your project in here now. We have this BentoML example. I'm going to go ahead and click into it. And this is our kind of little homepage. You'll get some neat summaries here. Let's go look at this profile tab real quick. We can see that we have one profile because it's batched daily. So we get a little bit of statistics about our data. This is way more interesting when you don't just have 3 API calls like we did, and you have multiple days of data. And we can look at this in a second. Let's go to this input tab, and let's go ahead and just click on the top one, pedal length. And here, this might be a little small to see. We're starting to get one profile logged per day, and we can see that this contains those summary statistics I was talking about, like the median, the max, the min, and right now there's no drift distance calculated on here. And then you get some other data about like the quantiles on about that data that was passed in. So we're starting to push all those API calls, that data, in here. And if we go to this output tab, we're starting to log our outputs as well. So we get the predicted classes for this day. And so like you could look at this variation over time of like, well, generally they're about, 50 this and 50 that. And then if it really changed one day, you might be like, well, what happened? Did something in the real world change that caused that? Or was it some sort of data drift and my model's not making predictions as well? And then you can log the probability output as well. And so this looks a little sparse with just our little bit of data right now, but it'll look something like this over time. So this is an example of 7 days of data here. And you can see that, this is the distribution for all these days. Like I can hover, get the median, the maximum, etc. for all these days and see them visualized here. And then I can see this one, it jumped up quite a bit. Let's just look at the median number. In this case, it went from 6.9 to 9.2. This other one is also, the data looks a little bit different. And then this one is all zeros. And you'll notice these little alert bubbles above them. That's because I set up a monitor in this case to kind of check that data. In this case, it was compared to the training data set like I talked about. So you can use the training data as a reference profile. And when this new data came in for this day, and the distribution of that data looked very different than the distribution of our training data, it triggered this alert here. And then that we can use to kick off like either a Slack notification, an email to us, or some sort of automated workflow with a PagerDuty integration. So this is what it looks like over time. And same with like you could go to this profile tab and you can compare profiles together. So if you want to get a little more statistics about what the distribution looks like together here, that's a useful tool. Let's get one that looks more similar. You can tell that, this data has a lot more higher numbers than the other profile is being compared on. So let's go back to our tab here. We'll go to, we'll go back to the code real quick. So I mentioned we're going to upload a reference profile from our training data set just so we could set up a monitor on this new data right away. So the cool thing about using a reference profile is you don't have to use or wait for production data to kind of populate and use some sort of rolling window comparison. You can start comparing right away. So we'll go to this data log. I copied over my API key and everything, and I'm just going to replace that. Easiest way to do it. Save. And then let's go ahead and call this data log profile. Again, you just call Python data log. And then this should write up to our WhyLabs. So now if I go into my profile tab, I can double check. I can see that there's this iris training data. And again, you can start comparing these. They look very different because the other one's incredibly small right now. There's just like a few data points in there. So the distribution drift is definitely going to be off. And also we can see already that, wow, there's some way out of the range because we put in ones that were like hundreds. So very different than our training data. Let's go to Monitor Manager. We'll quickly just set up a drift monitor. So I can use this preset one, but I'm going to configure it slightly. So that configure, instead of using this rolling day, a rolling window where we're looking at the last 7 days of our data and seeing if anything drastically changed there, we're going to hit reference profile, click our training data set there, hit save. We go back to our input tab, go back to that same feature, and we hit preview now. So again, by default, this is going to run every 24 hours and give you some sort of notification or however you set up those alerts to be if there is data drift or not. But we can hit preview to tune our model, and we can see that clearly in this case there was a lot of data drift because we put in those really high numbers. Also because we only had a few data points right now, our median and stuff is probably very different than whatever it was for our reference profile in this case. So we can see, I'll zoom in if you're not following along, some information about it and see that our drift distance, which there's different ways to calculate your drift distance. By default in WhyLabs, we use something called the Hellinger distance, and you can tune this kind of up or down. So if you want to make your alerts more sensitive, you could have a lower number. The higher the number is, the bigger the difference has to be to get that alert. And going back to here, if you go in the README, that's kind of like it for the follow along code part today, where we went through, we trained a model, we got up and running on an API locally. We were able to start monitoring our data right away. And then, Sean, I don't know if you want to talk briefly about anything around BentoML deployment. So the next phase, if people followed along, they did this locally. Maybe they also checked out the model store, and then they want to do a little bit more around actually pushing this out to, AWS or BentoML Cloud.
Yeah, so once you're happy with the models and the application itself locally, you can build the application here into a bento, which is an artifact that you can distribute and deploy to different targets. So with a simple command line BentoML build, you can convert this application that you see on the screen to a bento that's stored locally in a bento store, and you can push this bento to a remote bento repository and convert that into a deployable OCI image there. Or you can run BentoML containerized that will containerize the bento you built into an OCI image that's you can run with Docker. So once you have the OCI image, you can run it in anywhere, like your on-prem data center, or you can run it in the cloud environment with AWS Elastic Container Service, or you can run it with Lambda or any EC2, or basically any cloud that you want once you have this OCI image.
Awesome. And yeah, you can also just define any other packages you want easily in your bento file YAML. So if you want to use
That's
something
correct.
like WhyLogs or anything, you can just easily put it under the packages section.
Right. So here ensures that the dependencies you run locally also exist. Also, you run with the same version, same set of dependencies that you run in production. So basically, you get what you see is what you get properties. So you know that your local testing environment, your local testing deployment is exactly what you'll see in production, having that safety on mind.
Awesome. And with that, I know that's all the kind of planned content that we had. I'll open up if anyone has any questions about it. If you don't have any questions right now, or you might have them later, like I'd mentioned before, you can connect with Sean or I on LinkedIn's great for me, and also the Slack channel. So the BentoML Slack or the WhyLabs and Robust and Responsible AI Slack are great places to ask questions if you're following along or trying to implement this in your real world project and you run into an issue or just have a question. You can find us in those places. And Sean, do you have anything else you want to shout out or mention about BentoML before we go?
No, I think you covered it all. Take a look at BentoML open source project on GitHub. Join our Slack community to meet other ML practitioners around the world. Every day I'm learning super cool, super interesting projects. I worked on different teams around different places, different countries in the world. There's a great place to just to learn, also to share your experience. Lastly, thank you, Sage, for having this. I think I learned a lot by following through. So I saw this ahead of time, but even just hearing you talk, seeing the actual operations you do on WhyLog, it's a great learning opportunity for me as well.
Yeah, and I'm excited to do more examples or projects or workshops together. I think it's really fun. And I'll just also mention, I don't know if you mentioned it about your Slack channel, but you have really great AMAs with guests quite often.
Yes, we have AMAs periodically, and so we also publish them in the form of blogs. You can see the contents in a more condensed place. So yeah.
Awesome. And I'll do one quick shout out on the WhyLab side. We always have a bunch of events going on, often in the form of workshops, but we also like to have guests on as well. I think we actually had BentoML CEO on a while ago, and I just did a blog post recapping that. That was great. And then I'll just share a link in the chat if anyone wants to check out any upcoming events right now. You can find them here. And the next one is going to be Intro to AI Observability. So we go a little bit deeper into a lot of the stuff we talked about today, like data drift, and we'll be looking at model performance. And then we're doing one with Databricks, and then one with computer vision. So kind of like we saw today, but on computer vision data and models. We'll be using Keras and TensorFlow to fine-tune our own computer vision model, and then learn how we can look at images and monitor for drift. And then I have an upcoming one that's not on here yet, but will be soon, where we'll go even deeper into a lot of the monitoring concepts. So if you're interested in learning about detecting or monitoring for bias and fairness in your models, as well as explainability, be sure to check that out as well. And thank you everyone for attending. And if you do have any questions in the future, let us know. And I do actually see one popped up real quick that we could probably answer. I'm wondering how Bento handles cases where we want to add more features incrementally without retraining the entire model.
So Bento, I guess I'm trying to understand the question a little bit more. Bento, I guess BentoML does not really is not really opinionated about what features that you put in. Is really just the model itself that you train that supports the feature that you want to add in the future, and you can update your API to feed those features into your model. If I understand the question correctly, and feel free to clarify if I'm not understanding it right.
Yeah, or
Sage, do you have a
I don't think I have a better answer than that. Yeah, but just mentioning that, yeah, if the person wants to clarify or ask the question, maybe in the BentoML Slack.
Yeah, like find me on LinkedIn or on the BentoML Slack channel. So
yeah, but
I'm
I
happy
think just
to get this sorted out.
Like you were saying, BentoML isn't opinionated about that, so I think it depends on how maybe they're going to be setting up their model for that and serving the model. In my head, at least from how I read it, that would be the use case as well.
Correct. So if the feature, you can incrementally add the feature to, say, the input is in the JSON format. So you can incrementally add new features into the JSON, and from the API, you can fetch those features and then feed it into your model and get prediction results. So as long as the model itself supports the new features as added, the API can accommodate it with however whichever input types, whether it's JSON or pandas data frame. Yeah. So as long as you handle that in your model.
And it looks like they answered the question. They said, sounds good. Thank you. Thank you for the question.
Let me know if you have more questions.
With that, we will wrap up the stream. And again, if you do have any questions in the future, go find us on LinkedIn or the Slack channels. And it was great doing this workshop. Thank you so much for coming on, Sean, and sharing your BentoML expertise.
Thank you so much for having me.
Awesome. And we'll end the broadcast.